Hi, my name is Manoj, and in this episode I'm going to show you how to use AWS CDK to automate your infrastructure. Now, if you have a production application that is running on AWS, you must automate your infrastructure. Why would you do that? Because there are so many benefits to it. For example, imagine that there's a disaster and the disaster strikes on the region that you spin up your AWS resources. So you want to spin those resources in a different region so your users can use your services without much interruptions. But if you have created those resources manually in the AWS console, you have to do it all over again in that new region, and that's going to take a lot of time, and of course that you are in a lot of under a lot of stress, so probably you will make mistakes. So that is one of the reasons that we would need to automate our infrastructure so we can easily spin up our resources. Now, this is just one of the examples. There are so many other use cases where you would need infrastructure automation. For example, imagine that you want to create a white label product of your application. Then you can easily use your infrastructure automation code to spin up that white label product fast. Okay, so what I'm going to do in this video? So in this video, I'm going to automate the infrastructure that is required to run a front-end application that is written in React and also the back-end part of it, that is a RESTful API that is running inside a container. And then we are going to connect these two together and actually build an application from scratch. But hey, before going into the implementation, we are going to look at the benefits of CDK. And why would you use CDK instead of writing CloudFormation templates in JSON and YAML? So I'm going to discuss 5 main benefits that you will receive by using AWS CDK. And after that, we'll jump into the implementation. Now, if I explain what CDK in one sentence, that is a construct library which helps you to automate your infrastructure very fast. Now, here's the first benefit that you get from AWS CDK. And that is ability to use a preferred programming language to automate your infrastructure. Now, someone might have this question: I already have CloudFormation to automate my infrastructure, so why would I need CDK? The best answer is you can use one of your preferred programming language to code your infrastructure. It's not just configuration, this YAML JSON configuration, but actual programming code. CDK supports multiple programming languages. For example, TypeScript, JavaScript, C#, Java, Python, Go, those programming languages. I think they will be bringing more programming languages going forward. So you can pick one of these programming languages and start provisioning your infrastructure. And one of the main benefits that you get when you start using a programming languages is that you can use all the programming constructs. You can use selections, you can use loops, right? You can use this if then else logic to selectively provision a certain infrastructure based on certain criteria. And if you have a set of infrastructure to be provisioned, you don't have to repeat the code. Maybe you can use that use a loop, let's say for loop, to provision all these resources in one loop. So all these constructs that we usually use in programming can be used in CDK. Okay, here's the benefit number 2, the ability to use autocomplete and inline documentation. Now, this is another perk of using a programming language, because since a programming language, we can import different libraries, CDK libraries. Those libraries itself contain documentation, and it supports autocomplete, that is bound to your IDE. So you don't always have to refer back to the documentation to see what certain attributes are supported by this resource and so on. You can just type dot and maybe control space, and then you get a full list of methods that particular resource supports. With auto-completion, you will get the inline documentation of that certain attributes, so you will know what attributes to use and how to use that. Now, here's the benefit number 3, ability to use your infrastructure code alongside with your runtime application code. Now, this is one of the really cool features, because now you don't have to separate your infrastructure code from your application code, because CDK supports creating your infrastructure and also linking that infrastructure to the application code. Now, for example, imagine that you want to create a static web hosting bucket. So you can use CDK to provision that S3 bucket and enable static web hosting. Plus, you can link the HTML, CSS, JavaScript code into the S3 bucket as well. So when you are done with the CDK deploy, you will have the static web application and also your application will also be running. Alright, now let's talk about the fourth benefit, and that is the ability to use higher level construct in CDK to easily provision our CDK applications. Now CDK supports 3 levels of construct: level 1 constructs, level 2 constructs and level 3 constructs. Now out of these 3, level 1 constructs are really CloudFormation representation of a certain resource. Now imagine again you want to create S3 bucket. So in S3 you have a certain attributes that is required and that is optionally required when you are provisioning it using CloudFormation. So you can exactly have a map with those attributes in CDK. That gives you more control over creating your S3 buckets. Okay, so what about level 2 constructs? Now level 2 constructs again represents a particular cloud resource. Imagine it's the S3 bucket, but it's going to give you more abstract methods as well as some default values to provision that resource. Now let's take the example of creating an S3 bucket using a L2 construct. So in that case, you don't have to provide the values for each and every attributes. Of course, you can add some values for certain attributes, and you can also use some methods like add lifecycle policy method, and that is going to inject some of the sensible default values to creating a lifecycle policy for an S3 bucket. Now finally we have level 3 constructs. Now level 3 constructs are also known as patterns. Now the main reason there is a level 3 constructs do not directly represent one cloud resource. There could be one or more cloud resource that is being provisioned to accomplish a certain activity or certain task. The best example is there's something called application load balance Fargate service. Now the main purpose of this particular construct is to deploy containers on AWS in a scalable manner. So it's going to provision an ECS cluster that is powered by AWS Fargate, and then it is going to create a Docker image out of the folder that you specify, and then put that Docker image into ECR, the Elastic Container Registry, and then it's going to create an ECS service so it can create and manage a number of containers. Not only that, it's also creating a application load balancer that is in front of your ECS service, and your customers can send traffic to this application load balancer endpoint and consume the services offered from your containers. So that is the third type of construct. Now here's the benefit number 5, that is ability to use developer friendly CDK CLI. Now AWS CDK comes along with the CDK CLI, and we can use that CDK CLI to create a CDK project in the preferred language. You can use TypeScript, Java, C# or whatever the preferred language of yours, and initiate that project. And then once you are done with creating your resources in CDK, you can use CDK synth command to synthesize your CDK code to the corresponding CloudFormation template. Now one thing you should remember is that CDK is using CloudFormation behind the scene, and the main benefit is you don't have to write that entire CloudFormation template, which will be really long, and you just only have to write few lines of code to get to that long CloudFormation template. So once you correctly synthesize your stack, then you can use CDK deploy to deploy your stack to AWS cloud. Now after the first deployment, you probably want to update some of your infrastructure, and you can do that in CDK code, and then check the diff by using CDK diff, and it will show the diff of the cloud resources, so you know what cloud resources have been changed or added or deleted. Now those are the top 5 benefits I saw in CDK. Now you also know about it. So without any further ado, let's switch to the other side and start building a CDK app. Alright guys, so let's get started with our implementation. Now as you can see, I have written a blog post related to the theoretical aspects as well as the demo that we are just going to do. So if you go to this particular link, you can view this, and I'll put this link in the description as well, so you guys can follow along if you are doing that. So yeah, so this includes the theoretical aspects that we discuss about, and the top 5 benefits of CDK. And also, if you scroll right here, so this is the part that we are going to start now. So I have added all the steps that we need to follow along when we are building this application. So yeah, so let's get started. Okay, now I have the VS Code open on my left side. But before actually go ahead with these steps, let me quickly show you the architecture diagram that we are going to build with CDK. Alright, so this is a Fibonacci generated application, and it has both front end as well as the containerized backend. So in the containerized backend, we have these containers running, and those are managed by ECS service, right? And this ECS cluster is powered by AWS Fargate, and which is really cool because we don't have to manage any EC2 servers here. And then we have application load balancer, and this application load balancer is again connected to a CloudFront distribution. Now I have added the application load balancer as a custom origin to the CloudFront distribution, and all the requests that has this /generate/star is like wildcard, all the requests with this path pattern, they will be directed to the application load balancer. And the default route is /star, and the default request will direct to the front end bucket, and it will serve the front end application. Now why we added the CloudFront here? 2 reasons basically. We wanted to cache the request of the front end static assets, and also because we will be calling this application load balancer domain. If we directly call it, then that will be a different origin, and I have to like enable this cross origin request supports. But with the CloudFront here, we will be associating our SSL certificate right at the CloudFront level. So both these origins can be called with the same domain name and with different path patterns. So here at the CloudFront distribution, we are going to associate this custom domain. And yeah, we have Route 53, our DNS service. So it is always mapped to the CloudFront distribution. So all the requests to the domain will be directed to the CloudFront. Okay, so this is our architecture, and let's get started. So I have opened VS Code, and I will click open folder, and then I'm going to create a new folder in my desktop, and let's call it CDK YouTube demo. Create and open this. Okay, so first and foremost guys, we need to install a couple of dependencies. Now let me increase the font size just a little bit so you guys can see better. Yeah, even before installing the CDK, there are a couple of prerequisites. You have to make sure that you have AWS CLI installed for whatever the operating system that you have, and then you need to configure one of the IAM user credentials, and this IAM user should have administration permission, so your CDK application can also have access to all the AWS resources. So I'm not going to go over that. Apart from that, you need to have Node.js, particularly the Node.js version greater than 10.3. So with those 2 prerequisites installed, we can start installing CDK toolkit, and I'm going to install it using npm. So paste it and hit enter. Well, actually I have done that. I'm not going to do that, but then I can actually see the CDK version. So let me quickly show you the version that I have currently running, CDK -- version, that is 1.105. Okay, now I'm going to initialize the CDK project. Now as you guys can remember, previously we can use one of the preferred programming language to create the CDK project, and in my case I'm going to use TypeScript. So yeah, I will initiate a CDK project. Let me copy this command and paste it right here. So it is CDK init, and you have to add this flag -- language and then TypeScript. So if you want Java, then Java, and likewise. Now it's going to spit out some folders. Let's explore it in just a little bit. And also it has given us some of the useful commands. Now this is one of the useful command. and this will watch our TypeScript code, and whenever we do changes to TypeScript code, it's going to compile them to JavaScript. So let's wait until this is completed. And by the way guys, if you like this type of contents, make sure you subscribe to our channel because we are releasing a video on every week, and you can hit that notification bell icon as well, so you will be notified as soon as one of our creators released a video. Alright, so it is completed. Let me clear the screen and let's see what is the next step. So now we are actually going to build our application, the Fibonacci generator. So what this application does is basically from the front end, a user can request the value of a particular Fibonacci number. Then the front end will forward that request to the back end. So our back end, as I previously showed you, so this one, so it's a containerized RESTful endpoint API really. So it's going to calculate the result and send it back to the front end. Okay, let's start implementing our backend first. So in order to do that, I'm going to create a folder at the root level. Let's call it backend. And then inside this backend folder, let me go into this backend folder. Now inside this backend folder guys, I'm going to create a file. Let's call it app.js. So let's create it in JavaScript. Now this app.js is going to be our REST API, and we are going to use Express.js for this. Now let me copy the code from the blog, paste. So up here I'm requesting Express.js, and then I'm creating an Express.js app, and then I have added a couple of routes. So the first route is /health. Now this is actually required for our load balancers to make sure the server is up and running. Now we are going to Dockerize this server. And by the way guys, we haven't yet used any CDK. So right now what we are doing is building our backend application code. So this health endpoints, it's only returning a text called healthy with the status code of 200. And then I have another get route, and that is /generate/number. Now in the diagram you might remember, so there's this /generate path pattern. We direct to application load balancer, which will direct to this one of these containers. So there I am getting the Fibonacci number that user request, and then I will pass the integer value of it, and then I will generate the Fibonacci value for that particular Fibonacci number. So here's this simple calculation for that, and the output, then we are going to send it as a JSON. And finally we are running this Express server on port 80. Now we need to do a couple of things. We need to install this dependency Express.js. Let me take the terminal. So right now I'm inside this backend folder. Let me initialize another npm project here. Okay, so with that I got package JSON, and then I'm going to install npm express. Okay, I can test if the application works by doing node app.js, then app is listening on port 80. So now if I quickly go to a new tab and do localhost, hit enter, I will do health, then I'll get the message healthy. So our server is running. So now we can start Dockerizing this. So I'll stop this. So in order to Dockerize, we need to have a Docker file. So here in the backend folder itself, I'm going to create Docker file. And then I will copy paste this code, the Docker instructions, and save. So if you quickly look at this, the base image is Alpine image. So this is a very small image. And then we are installing Node.js into that particular image, because I think the Alpine image doesn't have much really. So we need to install Node.js and npm, and then we'll set the work directly as /app, and we are going to copy the package JSON file, write this one, because we can utilize Docker caching better with this. and then I'm doing npm install, so it's going to install this dependency, particularly the express dependency, and then I'm going to copy entire things inside this folder into app folder, and then I'm exposing port 3000. Okay, I don't want 3000, let's expose port 80. And finally we have the cmd command, so that is npm start. So what does this basically do is, once we create a container out of this Docker image, and that is going to run the container is going to run this command, that is npm start. Well, if we quickly go to our package.json, the start command is not here yet. So what I'm going to do right here is I'm going to add this start command, and that is going to run our server node app.js. And I'm going to do one other thing. So inside the same folder, I'm going to add a docker ignore file, and I will ignore the node modules, because we don't really need to copy this node modules folder when you are doing this copy command, because in a previous step npm run install is going to already create that node modules for us. Okay, so now we can actually test this. So I will do docker build and space period. So period is the current folder, so it will find the docker file from the current folder. So let's see. So my image is being built, so it's now running the npm install, as you see. Okay, so it is successfully built, and this is my docker image id. So let me just copy that, and I'm going to spin up a container with this docker image. I will do docker run -it in the interactive mode, and the docker id. Okay, you can see now our container is up and running, and I get the console log from the container itself. So let's check this. So right now I don't have a server running in my local machine, but if I do this, nothing happens. Well, I forgot to do the port mapping, so let's do a port mapping to map the host port to the container port. -p 80 to 80. Do a small change. Okay, let's check this time. Yeah, I think now it is working. So we can check the health endpoint again, healthy, and also let's try that generate endpoint. Generate slash, let's say 5. There you go. The output is also 5. Let's try a different number, 10. So the Fibonacci number 10th is 55. What about 20? That is 6765. Okay, now our application works great. Stop this server. Now guys, I think we are done with the backend implementation. So as our next step, we are going to provision the backend as code, and this is where we are going to use CDK. So at the root level itself, I'm going to create a file inside this lib folder. So inside this lib folder, so right now I have one of these sample CDK file. I will leave as it is, but I'm going to create a new file and call fargate.ts. So why did I name it as Fargate? Because we are going to create a ECS cluster that is powered by Fargate, and then we are going to instruct CDK to create a Docker image out of these files inside this backend folder, and then upload to ECR. Now if you guys don't know about ECR, that is the Elastic Container Registry. It's just like Docker Hub, but proprietary Docker image repository in AWS, and then ECS will use that Docker image to create containers inside its ECS cluster. And together with that, we are going to create an application load balancer, and to do all these things we are going to use a level 3 construct. let's first go ahead and copy this code and discuss afterwards. Paste. And I'll expand the code so we can see the code better. So here up top we are requiring some of these dependencies. Now CDK is a construct library, as I already mentioned. So we can require different constructs. So right now there are a couple of constructs. So first let's go ahead and install this and discuss afterwards. So I'll do, so right now I'm in backend, so let me go back and I will go to the lib folder, not to the lib folder but to the root. So right now I am at the root level, and then I'm going to install, because my package JSON outside is at the root level, right? So I will install these three dependencies that I don't already have: EC2, ECS, and also AWS ECS pattern. Now this is our level 3 construct, guys, and hit enter. So while it is installing, let's go over this. Now first and foremost, guys, in order to create an ECS cluster in the Fargate mode as in like the serverless compute, we need to have a VPC. So that's why I'm creating a VPC right here. So for that I'm getting this VPC from AWS EC2 construct, and I call this VPC as YouTube VPC, and then I have defined 2 availability zones maximum and also one of the NAT gateways as well. Now this is going to create private subnets and public subnets. Now what is private subnet? In a private subnet you don't have a route out to internet. That means whatever the resource that we added to the private subnet cannot talk to internet, and our containers are going to be in our private subnet. Now through this NAT gateway our ECS cluster can connect to ECR and download the Docker image. So that's why we have this VPC, and then we are building the ECS cluster that is powered by Fargate, and here I'm going to use this ECS construct. So ECS.cluster, and I call this cluster YouTube cluster, and I'm setting the VPC that I just created for this cluster previously. And then I'm going to use the third construct, that is the level 3 construct, ECS pattern, which is this one, and this is going to do a lot of things for us. So as you can remember, this is that application load balance Fargate service I've been talking about, and there I can define what my cluster is and how much memory am I allocating to a particular container, and how much CPU am I allocating to a container, and how many containers do I need to up and running all the time. So I set the default or desired count as 2. So our ECS service will make sure if one container goes down, it's gonna create another container for us. And then I have to define the task image or the Docker image for our container, and there I'm using this ECS dot container image static method, and there it has another method called from method, and here I will just go one directory up and then into this backend directory and get the content inside it. So this construct is smart enough to look at this content and get the Docker file and create a Docker image and put it to ECR or Elastic Container Registry as a Docker image, and then have a reference to it in our cluster. So our cluster is able to create a Docker containers from that image. And optionally we can pass some environment variable. Of course in our case we don't need it, but imagine now if you have a use case where your containers need to talk to a database, so you can reference those database URLs or the database strings through secret manager or parameter store variables. So that's all to it for our ECS pattern, and this is going to create all of this stuff. So it's going to create our ECS cluster, and it is going to spin up 2 containers through a ECS service, and these container images are taken from ECR, so I haven't like represented the ECR here, and it's going to create the application load balancer as well. So it's doing all this stuff for us. And finally, I'm setting the health check endpoint because our application, we already have an endpoint called /health, and this has been particularly useful for our application load balancer to check the health of this container. And finally, I'm exporting this load balancer URL because we need this load balancer URL when we are configuring our CloudFront, because we are setting this application load balancer as a custom origin to it. So we need the ALB URL or the DNS name to reference it in CloudFront. So that's why I'm exporting here, so I can import it in a different CDK stack. Alright guys, so next I'm gonna go ahead and deploy this and test this on AWS. So in order to do that, I will go to bin folder, and there's the CDK demo TS, right? And right now, if it is requiring the CDK YouTube stack, this default one. So let me just remove this one, and here instead of this reference, let me import our fargate.ts. Great. And in Fargate, we are exporting this Fargate demo stack. So let's use that one. Great. And then we first create a CDK app, app cdk.app, and then we are going to associate this stack with that app. So let's reference this one. And guys, when you are deploying a stack, we can define to which account should we deploy these resources and in which region. So that is where this environment variable or object comes in handy. Let me uncomment it, and then I will associate my demo AWS account ID and the region that I want to deploy this to. So here in AWS, I can find my ID here, paste, and I will deploy it to US East 2. Well, I'm going to change the region, by the way. I'm going to pick a different region, that is the North California, because I already have some of these resources provisioned in this region, and I'm going to get some errors otherwise. So I'll do US West 1 region. Now before we deploy, I want to bootstrap. So CDK is going to create some of these CDK assets. So I'll do CDK bootstrap. So it is bootstrapping my environment, and it's creating the CDK toolkit resources. Now if we really look at the blog post, our next step, step number 5, it is building the front end React app, but what we are doing here is step number 7, that is deploying our backend first, so that we can check if it all works. Okay, so the bootstrap is complete. Now I can go ahead and deploy my stack. Now even before I deploy my stack, I'm gonna run npm run watch. So it's going to convert all my TypeScript to JavaScript. So you can see all my TypeScript files have compiled to JavaScript. So let me take another terminal, and now I will do CDK synth to synthesize this stack. So it's going to create the CloudFormation template that is related to our Fargate stack, and it will show us any errors if we have. Well, you can see this is our CloudFormation stack. It's a long CloudFormation template. I mean, we were supposed to write all these things if we weren't using CDK, but with CDK it's only how many lines? Very few lines, right? Less than 40, I believe. So this is the beginning of our CloudFormation stack, and it goes all the way down. So thankfully I don't have any errors. So now what I can do is I can do CDK deploy. Now here we need to confirm, is this what we intend? Because CDK is going to prompt us a confirmation when it is doing some IAM related resources or creating some IAM related resources, because these are security, right, issues or security concerns. So let me say yes, I wanted to create all these security groups and IAM roles. Hit hit enter. Okay, let me take myself out of this. Now as you can see, it is deploying our infrastructure, and look, it is building our Docker file as well, and this Docker image is going to be sent out to ECR, and then it will create this ECS cluster and the ECS service, and also the task definition, and this task definition will refer to this Docker image, and then it's going to create those two containers I set it here. And not only that, it's going to create the application load balancer as well. So let's wait until the end of this. It's going to send me the load balancer endpoint because we ask it to export that value here. And guys, I think this will take some time, so I will pause this video and come back once it is done. Alright guys, so I'm back and it is completed. So as you can see, so it has output the load balancer URL, which is this one. Very nice. So let me command click here, and I will open this up. There you go. Let me put it in the full screen. Right. So it says cannot get, and let's try our /health. I should get healthy. Very nice. So it seems to be our backend is working. Let me do generate 10 to generate the 10th Fibonacci number, and there you go. I got the output 55. Okay, so it all works, which is really nice. Now we can go ahead and continue our backend. Okay, so now we can go ahead and develop our front end. For that, I'm going to start at step number 5, which is building the front end React app. So we'll first build the app, and then we will provision the infrastructure that is related to deploying that particular app. So here I will create a new folder. Well, I'm not going to create a new folder, but I will take a terminal that is open up at the root. If I do pwd, yeah, so I'm at the root, and I'm going to create a React project. For that, I will use npx create React app, and then let's call this front end. I think it will create a front end folder together with this one. Let's see. Okay, you see, all right, I see the front end folder getting created. Now it is installing the dependencies, and once it is done, we are going to copy this code into app.js file, and this is going to give us a very simple UI. I think just one input box and a submit button, so I can type in the number, the Fibonacci number, and then submit the request to backend. I will get this copied. So while it is being provisioned, let me quickly go to my diagram and show you what we are going to do. So we are going to create this front end S3 bucket. Now in this S3 bucket, we are going to deploy all the compiled JavaScript, HTML and CSS files. So it's basically our front end app. And then we are going to set up another origin, a S3 origin from CloudFront to that particular S3 bucket. And guys, we are also creating an origin access identity. So that means only the origin access identity can access this S3 bucket. So this way I can prevent direct user access to S3. And apart from that, I'm going to create this behavior /star. So this is the default behavior. So if none of these URLs that's coming from the users do not match /generate, then everything will be directed to the front end app or front end S3 bucket. Thereby the users will receive the HTML, CSS, JavaScript images that our front end app holds. Okay, so let's see. Okay, it is completed, and now I will go to the source folder. I will go to app.js, and here I'm going to replace one that I just copied. Now we need to do a couple of changes, guys, because currently the blog post has the domain that I previously registered, so that is enlearacademy.tk. but this will not work. But let's see how it all looks like in the browser. So it's basically we have a div and the heading Fibonacci generator, and I have a form. So in this form I'm expecting a number into an input box, and then there's another button called generate. So let's see, I will do yarn start. Oh, I need to go into my front end folder, and let's do yarn start. Well, there seems to be a problem with the jest dependency, that CDK install and the React app install. So let's see what it asks me to do. Well, I'm not going to go through all this setup. What I will do is I will skip this, because this is just a demo. So I will go there and I will create a .env file, and then I will add this keep pre-flight check true. Okay, and then let's do yarn start again. Yeah, this time it works. So let's maximize the window. Here we go. Ooh, that's too big. So I have this Fibonacci generator. Now let me increase the size just a little bit, and I can type the number and then click generate, and when I click generate, then it's going to call upon the handler. So this is the handler function. So in the handler function we are using fetch API to fetch the result from our backend. So right now this is not going to work because we haven't set up our custom domain yet. So instead what I will do is I will quickly get the ALB URL or the endpoint, copy that, and then paste it here instead. Let's see if this works. And now I will go to React app. Let's take a terminal just to see if I get any errors. Network. Okay, I will type number 10, generate. The request goes out. Ooh, I get the cross error. So right now we are calling our API from localhost domain, and the application load balancer domain is a different one. You see, it's a different one, right? Because these domains do not match, we get these cross errors, and to prevent that we will use a CloudFront distribution. So I'm not going to test it right now, but let's go ahead and start provisioning our infrastructure. So that is step number, let's see, what is that step? Step number 6. Now in step number 6, I will create another file called CloudFront TS. Now this is our CloudFront stack. So in our lib folder, so right now I have this Fargate TS, and I will create another file called cloudfront.ts. Okay, and then I will go ahead and copy this and paste, save. So I'm requiring several CDK construct, AWS S3 and also S3 deployment, and then I'm requiring CloudFront origin because we need to create CloudFront, and also AWS certificate manager. Now first let's stop the front end server and go one directory up, and then I will install these dependencies. npmi, I don't think we install this one, but I think I already have it in my system, that's why it's not showing that quickly, but let me install it anyways. And also AWS certificate manager. Hit enter. So while it is getting installed, let's go through the code. Oops, we forgot to install CloudFront. Let me see if I already have it. Yes, I think I already have it, but you guys might need to install this one as well. So if you look at our stack, so it is called CloudFront demo stack, and this is basically provisioning this resource, this set of resource, basically these two really, CloudFront and the front end app. So in CloudFront, first we need to create an origin for the application load balancer, and also we need to create origin for the S3. So if you really look at it, we are importing that load balancer URL that we exported in the Fargate stack. Let me go to the Fargate stack. You see we export it as load balancer URL. So this is export name. So I import it with cdk.fn. So these are some static methods I can use to import or cross-reference different stacks. So I load balancer URL. So here I get the string, and then I will get to this one and this one just a bit. What I'm going to do is I'm going to create this S3 bucket, because we need to create S3 bucket, right? We don't have S3 bucket. We are going to put that front end build code into the S3 bucket. I'm newing up a bucket. So bucket is from AWS S3 CDK construct, and then I call it website bucket. I don't enable versioning, and removal policy I set to destroy. That means when you are removing this or CDK destroy, it's going to like remove that bucket as well. We can also use other values, like we have retain and destroy. So I'll set destroy because this is again a demo. Okay, so this will create that S3 bucket. Now that S3 bucket is going to be empty, so we need to put that build files. Now this is a very good example that we are using both the infrastructure code as well as our application code together. Now here I'm creating a new deployment. So deployment is again from AWS S3 deployment construct, and there I call it website deployment. And as for the source, we need to define where can I find the build code. Now my build code is available in the front end directory, and once we do react build, then it's going to create a build folder. So let me in fact do that just to make sure. I will take a new terminal and go to cd front end and then run, what is the build code, sorry, package.json, npm run build or yarn build, I think npm run build. So this should create a build folder. Let's see, there you go, here's the build folder. So it is still creating the files. Let's wait if it is going to create any subfolders. Yep, it has created a subfolder called static. So I need to reference this static folder inside this build folder. So I will go to CloudFront. So my bucket source is source.asset. Now this source is coming from AWS S3 deployment, source.asset, and I will go one level up. And from my previous previous experience, I need to refer CDK, YouTube, demo, this top folder, and then I will go back to front end and then build and /static. So with that, we create the S3 bucket and we deploy the build HTML, CSS, JavaScript into that S3 bucket. Then we are going to create that origin access identity, because as I previously said, CloudFront create our OAI to access this front end bucket. So here I'm going to create an origin access identity from CloudFront, and then I use this origin access identity in my CloudFront distribution. So this is the CloudFront distribution. So I'm creating a new distribution. So the distribution again is coming from AWS CDK CloudFront construct, and I have to provide couple of attributes. Now as for the default root attributes, I want to load that index HTML of my S3 bucket. So I define index HTML, because you see inside static folder I have index HTML, this one, right? And then the domain name. So at this point I can attach a custom domain to my CloudFront. And guys, I have actually obtained a new domain. If we go to AWS account and go to Route 53, and here we go. So this is the new domain I created, enlearacademy.tk. Now I'm not going to include this step in this demo because I already have created video on this. I think that's the very first video I released in this channel, hosting a web application. So I'll refer a link here so you guys can go ahead and see how to create a custom domain and set up these name servers with that custom domain. So another thing I just wanted to show you is the SSL certificate that is attached to this domain. So I also whitelisted an SSL domain. If I go to ACM or Certificate Manager, Amazon Certificate Manager, I'll open it in a new tab. So once you all have a custom domain, you can go to ACM, AWS Certificate Manager, and make sure to go to North Virginia region because CloudFront accepts certificates from North Virginia region because CloudFront is a global service. You can click request a certificate, request public certificate and request certificate, and here you just have to give the domain name, whatever the domain name that you want to attach to your application. So I went ahead and already got a SSL certificate, and that is this one, and you should see the status as issued, and then you can just copy this ARN. Just copy this ARN. Now I'll go to my code, and here in our CDK project, at the root directory, you should see there's a file called cdk.json. Now in the cdk.json file, we have this context object. Now in this object, we can pass in any external values and we can refer it in our CDK stack. Now here in this CloudFront CDK stack, I skipped this two step on purpose. As you can see, I am using this .node.try get context, and I have this context variable called stages. So let's go ahead and create that. So inside this context, let's create that object stages, and that's another object. So inside this stages, so I'm referring to the current stage, and that I got from my props. So I can pass in any stage value when I am executing this CloudFront demo stack. You see I have attached a custom interface called custom stack props, and there I am particularly looking for a value called stage. So that's what we are referencing it. So let's call that value and we'll call it prod. And also you can have, let's say if you have other stages like dev and test, you can associate any stages for your application. And there I will have attribute called certificate ARN. So this is that config.certificate ARN that we refer. So I will add certificate ARN. For this certificate ARN, I will just paste in that ARN value. I think I lost it. Copy this ARN for my SSL certificate and I'll paste it here. Great. Now this is a neat way of importing different constants value into your CDK stacks. So you can always use context object, right? And the context object you can refer it stage wise as well. So here I am referencing ACM or Amazon Certificate Manager certificate from a certificate ARN, and the certificate ARN is coming from my config file. So I get this certificate and I will get that certificate ARN and I will attach it to my CloudFront distribution. See, for my certificate attribute, I'll set the certificate ARN, and the domain name I will set the same domain name because the domain name for this certificate is Enlear academy.tk, so it's the same domain name here. And then I'm setting the default behavior. Now, as I have already shown you our default behavior, you see this one is our S3 bucket. So I am referencing my S3 origin. So for my origin attribute, I will new up a new origin, S3 origin, and set my S3 bucket, which I created previously. And also I will associate the origin access identity that I created as well. And I will set some of the other attributes as well, compressed to true. That means all the content will be compressed, gzipped. And I will set the allow methods to allow get requests. So the CloudFront can issue GET request to my S3, and also so I've set the Weaver policy protocol, protocol.allow all. So that means our CloudFront distribution can access the origin using HTTPS as well as HTTP. Now if I just remove this and click type dot, you see I have the option to select HTTPS only or redirect to HTTPS, but I will set allow all here. So with this, it should create a CloudFront distribution. So this CloudFront distribution, and create the S3 bucket and set up this connectivity. Now I need to create another origin, and this is a custom origin. So that is what we are going to do next. And here I am creating a custom origin for the application load balancer. So I will again new up a origin, and this time it's a HTTP origin. And as for our HTTP origin, I'll pass the load balancer domain. Now you can remember, right? I imported that load balancer DNS name up here. And then I'll set the protocol policy to HTTP only. Because my load balancer, as you guys have already seen, let me see if I can show it again. So this is a HTTP endpoint. So it's not secure. So when CloudFront trying to access that, we need to particularly say it's the HTTP only. Now don't get confused, guys. We attached our SSL certificate to the CloudFront. For all the communication from the internet users to our CloudFront will happen through HTTPS protocol. And then here it will happen this SSL termination or TLS termination. And after that, connecting to those application load balancer will happen through HTTP. Now if you also want to secure this connectivity, you can attach SSL certificate to your ALB, but that is out of the scope for this demo. Okay, so we create that HTTP origin, and then I'm creating the /generate behavior. There we go. So I add /generate /star, and I'm allowing all the get post requests to my ALB origin. Alright, finally I output the CloudFront domain URL. And now let's go back to our bin and CDK demo stack, and let's add this stack to our CDK app. So here I will just take a copy and paste it. This time I'm importing CloudFront, and this stack, I believe it's called CloudFront demo stack. CloudFront demo stack. And let me take another copy here, paste. So this stack is our Fargate stack, and this is our CloudFront stack. Copy, and I will replace the same name here. And also I set the env to the same account ID and also US West 1. But now I get a squiggly line because we need to add another variable, and that is called stage. Now do you guys remember we have a custom interface for that, and I will add the stage prod here. Now if you missed that, let me quickly show you again. In CloudFront we are using this new interface or the custom interface, and I'm setting my props to reference that interface really. So it is expecting a stage. Okay, I believe this should do. So let me go ahead and deploy this stack. So I'll go to my root directory. So I'm here at root directory, and I can now do CDK deploy. But now that we have two stack, I can particularly define which stack do I want to deploy. For example, I can say CloudFront stack. If I don't do that, it's going to deploy both the stack. Since I already deployed this one, let's call it CloudFront demo stack. But before doing that, I need to do two things really. First one is I need to change the API endpoint in my front-end application. So here in my front-end app, okay, not this one, front-end folder, source, app.js, Now I need to revert this back to http.enlearacademy.tk and /generate/number. So that's the first thing, because we associate this Enlear Academy domain to the CloudFront distribution. And the next thing is, let's synthesize our stack and see if we have any errors. synth, hit enter. Now this should return the entire CloudFormation template. Yeah, I need to supply the stack ID for this command as well. So let's do CDK synth, this time CloudFront demo stack, because previously we already tested Fargate demo stack. Let's see if we have any errors. Okay, no errors, and this is our CloudFormation template. See, again it's a long template. Okay, all in all, looks good. So now I can deploy CDK deploy, and I will deploy the CloudFront stack, CloudFront demo stack. I will agree to create all these IAM related resources. So this will also take some time, so I will continue once it is completed. Okay guys, so it is completed, and you can see this is our CloudFront domain name. Now let me copy that and take a new window and add HTTPS in front of it, and then paste it and hit enter. Well, I get this access denied error. Now I can get rid of it if I go to AWS, and in AWS console I will go to CloudFront. Now in CloudFront, you can see this is our CloudFront distribution. See, the CNAME attached to it is called enlearacademy.tk. So let me go into that, and then I'll go to origins. So in origin I see both my S3 origin as well as the custom origin for the load balancer. See, this is our load balancer origin, the DNS name of the load balancer, and the S3 bucket. Now here let me go to our S3 origin, which is this one, and click edit. And here you can see our OAI is also attached. Is the OAI, but I haven't granted the permission such that my OAI in the CloudFront can talk to my S3 bucket. So in order to do that, I will click yes, update the bucket policy of that S3 bucket, and then click yes, edit. With this, I should be able to refresh this page and view my application. Let's see. Still not. Probably my CloudFront distribution is still in progress. There we go, still in progress. Let's wait until it is completed. But that step is not added in my CDK code. Probably I will add it later. Let me do another refresh here just to see. Still not. Now in the meantime, I will go into that S3 bucket and see if my files are already there, so that I can confirm. I will just copy the first part of it. So this is the bucket name, copy that, and I'll go to services and S3. Search for the bucket, and this is it. Go into that, and let's see if I have my index.html and other files. Well, I don't see my index.html file. Now this is another problem. So let's fix that first. So I think I know the issue. Well, I don't really have to go into that static folder, right? Is that the issue? Build, and the build folder is just enough. Let me just take out the static, right? And I will just leave the build folder. Yeah, sorry, I think it's my mistake, guys, because in the static it has only CSS and JavaScript. Oh, that's a blunder. Okay, let me do another deployment. CDK deploy CloudFront demo stack. So the website deployment is now happening. As soon as it is completed, I should see my index.html files there. Okay, it is completed. Let's do a refresh. Hopefully I should see the index.html. Yes. Okay, this time it quickly got it deployed, because a lot of my resources are already created, right? It just needed to update the diff. So this time I will come to my CloudFront DNS and then do a refresh. And there we go. I see my front-end app. Very nice. How about I will take another terminal and I will use the custom domain. So the custom domain is enlearacademy.tk. Hit enter. Well, I don't see that. Why is it? Well, that's the one reason. Because we need to do one other thing. In Route 53, I have this enlearacademy.tk. But right now, it is not referencing the correct CloudFront distribution. Probably in your case, you wouldn't see this record at all. So in that case, what you should do here is just create a record and create this Apex record, and then select it's a record and select this alias, and then select the CloudFront distribution, and then you should see the correct CloudFront distribution here. So I'm not going to create a new one, but I will do is I will edit this one. Click edit record and remove this one and attach the correct one. So it is D1P1, right? So if I go to here, so that is D1P1, you see. Okay, and then I click save. Now DNS resolution will take a little bit of time, but let's try our luck. Still not. So we should wait a few minutes, and after that we should be able to access our application through enlearacademy.tk. Alright guys, so now the DNS is resolved. You can see enlearacademy.tk has loaded my application. Very nice. Now let's use this application and see if everything works fine. So I'll take a inspect element, go to the network tab, and then let's request for some Fibonacci number. So I'll add 10 and then hit generate. Well, I got another cross error, but we fixed it, right? Let's see. I think I know the issue really, guys. Although we fixed it here, we could not really build this application, because as you remember, the content of this bucket is being referred from the build folder. So I need to build it. So let's quickly build that. Go to front end and do npm run build. Okay, it's built. Okay, let me show you one other CDK command before we deploy this. So that is CDK diff, and I will check the diff of the CloudFront demo stack. Now what this command will do is it will show us all the changes that we have done to our stack. But let's go ahead and change this bucket version to true. So right now the bucket version is false. I will set it to true, and then we'll do CDK diff again. Okay, now if I scroll down slowly, I should see the versioning configuration. Well, for some reason for this particular theme it's not properly showing, but this is the resources section, and this is the versioning configuration. The status is now enabled. So I will disable it again because I don't want to enable it. Now let's do CDK diff again. I'll scroll a little bit up. This is the resources section. Now I don't see that change. Okay, just to show you guys just this particular command, it is useful to see what has been changed in your CloudFormation template. Alright, so now I'm ready to do CDK deploy once again for our CloudFront stack. Alright, so it is completed. So let me go back here and do a refresh, and let's try one more time. It still says there's a cross issue. Now this is because, guys, we need to run an invalidation. Now we can trigger invalidation at the end of this CloudFormation stack, but I'm not going to edit right now instead. So let's go ahead and run that. So I'm at AWS console. I'll go to CloudFront. And for my Enlear Academy CloudFront distribution, go to the invalidation tab and create an invalidation #star. Now we can run this invalidation in the code itself. For example, here towards the end of this CloudFront stack, I can run a invalidation. But I'm not going to edit here. You guys can probably look at the CDK documentation and figure this out. I will add 10 and generate. Okay, so this time I got the result as 55. So let's add 15. Okay, so this is the result, and I will try another one. Okay, so this is the 25th Fibonacci number. Now I want to quickly show you the backend resources that it had configured. So here we go. Now this is our CloudFront distribution. So this is the Enlear Academic CloudFront distribution, and then we have two CloudFront origins, S3 bucket and also the Fargate backend. Now we already saw the S3 bucket, but let's look at the Fargate backend. Now this is the DNS name of the application load balancer. So I can go to services and I will go to EC2 service. So that's where I can find the application load balancer. I will go to the correct region. So my region is US West 1, and there I should see one load balancer running. So I'll go into that. So this is our application load balancer DNS. And then if we go to the listeners, so all HTTP requests to this particular cloud application load balancer is forwarded to this target group. So let me go into this target group, and I'll open up this target group as well, and I should see there are two healthy targets. There we go. Now these healthy targets are nothing but our two containers, and you can see the IP addresses of those two containers. Now let's go to ECS and see those containers in the ECS console. So this is our stack and two tasks running, and then I'll go to the task section. I see these two tasks, and you can also see this particular ECS service set the desired count as 2, and I can even change that if I change the desired count number here in the Fargate stack. So currently I have set the desired count to 2. Alright guys, so this is what I want to show you, and one bonus point before I end up, and that is about CDK pipeline. Now in this demo we only did CDK deploy manually to deploy our stack. But when you're actually working in a project team, a lot of people will start contributing to your project. So that's where you would need a proper CI/CD pipeline or continuous delivery pipeline. And you can easily create a continuous delivery pipeline together with your infrastructure code using CDK pipeline. So here it is, and I will just show you one of the blog posts that they have released. So this is the CDK pipeline blog post, and I'll put the link in the description as well. You can go over it. And if you guys also want a video in CDK pipeline, let me know in the comment section. I will create one. Okay guys, so alright, so one very important thing before we wrap up, we need to destroy this stack, because the load balancers and the Fargate cluster, so those things are going to cost you. So in order to do that, I will go to the code and let's use CDK itself. Let me clear the screen and make sure you're on the root directory, and then let's do CDK destroy. Before hitting enter, make sure both of your stacks are available right here, and then hit enter. Okay, so it asked me to add this all flag because we are removing multiple stacks. So let's add that. Yes, I want to delete. Hit yes. So now it is destroying. Okay, now it says there's a dependency for the cloud front. So what I will do is I will just do CDK destroy, and first I will select CloudFront demo stack. And after that, once this is complete, I'll again do CDK destroy for our second stack, the Fargate demo stack. Yes. So now it is being destroyed. You can see delete in progress. Okay guys, I'm not going to keep you waiting, but make sure you destroy the CloudFront demo stack first, and then again issue a CDK destroy command for the Fargate demo stack. Alright, so this is what I want to show you in this video guys. I hope you guys enjoyed it, and I'll see you in a new video.